Right, so we're really going the opposite for your function of function rule. So you got the integral of a x plus b all to the power of n dx. Okay, so we differentiated, we brought that power down, took one off the power, and then multiplied by the derivative. Okay, so we're doing a similar process when we're integrating.
This is what we're supposed to be doing in drawing.
Okay, so say again, when you differentiate ax plus b all to the power of n, you bring down the power, write all that, take one off the power, and then multiply by the derivative, or by a inside that bracket. Okay, to go back the other way, ax plus b, you add 1 to the power when you're integrating. Alright, you then on the bottom divide by by the new power, just like we've been doing the example, and you also need to multiply on the bottom the derivative of what's in the bracket. Okay, and of course we have our constant integration there. Now, this only works when this is a linear function. Okay, you cannot use this rule when you have another power of x associated with it. Alright, so if you say ax squared plus b, you cannot use this rule. Okay. Alright, so proof 1.3. So we just make sure we're getting this and verifying. Okay, so we need to do a dx of that. Okay, so we're going to verify it by differentiating our result, and we should get what's here before the integrand symbol. Before the integral symbol, which is also called the integrand for memory. Okay, so differentiate. We have a function of a function. Okay, so we need to bring down the power. Whatever is inside that bracket gets reproduced. You take one off the power, and then you have to multiply by the derivative inside the bracket. So you have to multiply by a to differentiate, and then you still had the a n plus 1, which is of course a constant number. Alright, cancel because we are multiplying. Then 1 take away 1 is 0, so we have ax plus b to the power of n. Right, so we're just formally showing that it works. Having a bit of trouble keeping your hand to yourself, eh? Okay, so again, this only works if what's inside the bracket is linear. Okay, if it's not linear, it will not work. Okay, and the extension students will look at ways where it is not linear and how we make it work.
Yay!
Very enthused reaction there.
Look at like just anger on Lily's face.
Alright, so let's try some. A integral of 4x plus 5 to the power of 3 dx. Okay, so when every term is grouped by power, you could of course expand this out and integrate bit by bit. Alright, but if we know the technique of what we're doing now, the function, we can do it much quicker. Alright, So 4x plus 5, write what's inside the bracket, add 1 to the power, okay, just like we've been doing with powers of x, divide by the new power, multiply on the bottom by the derivative, okay, so the derivative is 4, coincidental, same number this time, and don't forget your constant of integration. So 4x plus 5 to the power of 4 over 16 plus c. And we can verify our solution by differentiating, and we should get that same answer. You just turned it on to annoy her, didn't you?
No, it just turned itself off.
Hey? B, the integral of the cube root of 6x take away 1. Yes.
Wait, is that for multiple?
Okay.
Is that for multiple rooms?
No, it only turns it on. That switch only does these bands.
No, because Robin did it. Robin
It's
thought it was
a
Robin.
regular page. No, it's not even a light, so it's not a regular power.
Regular power outage. How will you ever regular power outage?
Nice to know that a fan stopping and taking effects away from integration.
Attention span.
Right.
Attention fan.
Yay.
Anyway, so we need to rewrite this.
6x take away 1, all to the power of 3 over 2.
Incorrect.
No, 2 over 3.
Incorrect.
No, 1 over 3. Third time lucky.
You broke it. Settle down.
So please move to a room where it's not broken.
Okay, let's get this done. Right. So remember that the nth root of x to the m, right, using your index laws, right, so the nth root of x to the power of m is x, the numerator stays with the base, and the denominator is the root power, alright? So this one, n is 3 and m is 1, alright, so that means the power is a third. If you don't remember that, you need to go back and look at chapter 1 of your prelim text.
The good old days when things were simple.
Okay, so now we can integrate that. Remember, this is the linear function. So 6x plus 1, sorry, take away 1. Add 1 to the power, so third plus 1. I would recommend you write them as improper, which just helps with the converting back. Divide by your new power, then you need to multiply on the bottom the derivative of what's inside that bracket. Okay, so the derivative of 6x take away 1 is 6. Don't forget Charlie. Okay, so the fractional power, I know it's a surd. Okay, the numerator stays with that. Stays with the base. The denominator becomes the root power. And cancel out there, that's why we write them in proper. We can do some cancelling more straightforward. 4 times 2, which is 8, plus your constant integration.
Does this cube root and this the 4 cancel out?
Say again, sorry?
Could you cancel out the cube root and the 4? There's no.
Oh. And as an exercise, you can write up a very detailed constructive proof of why you can't do that. Okay, C. The integral from 3 to 0 of 2x plus 4 to the power of 2. Okay, so now we have a, what's it called? We don't have an indefinite, we have a definite because we are given values to integrate with respect to. Alright? So, when you have a definite integral, we do not need to include the constant because it will be eliminated once we do the working. Now you have a couple of options. You can expand out, because you all know how to expand out a perfect square. Okay, so you can do that, integrate 3 terms if you wish, or you will use this rule. Alright, so 2x plus 4, so what's everything in the bracket? Add 1 to the power, divide by your new power, multiply on the bottom by the derivative of what's inside that bracket. Okay, and because I have the endpoint of integration, right, I don't need to include the constant integration, and I will write the endpoints 3 to 0 because it's a definite integral. Alright, so we've got 2x plus 4, all to the power of 3. I'm just tidying it up. Okay, you don't need to as such do this, you can incorporate that in your working. Okay, so remember when we're integrating, we do an f of capital F of B and capital F of A. So every time there's an x, we put 3. Take away. Now this is only one term because it's already factored. Alright, however, I would recommend when you do this, you always have a bracket. So 2 lots of 0 plus 4, power of 3 all over 6. So that's 6 plus 10, 3, so 1,000 divided by 6. Away 4 over 6. Okay, and always have fractions simplified down to simplest form.
How did that to right?
Okay.
Why is over 1,000? So 6.
Oh. Sorry.
I wrote that and then
Now we can
crossed it out.
factorize it down.
Good, I was just testing you.
So it's 100, 150,
12.
156. Yes, 156.
9,
156.
3, 33, 150, 36. Yep, good. 156.
So I wrote out like
So you did.
yeah.
Okay, so you can see that I make mistakes pretty easily as well, just a bit careless. Alright, so we need to make sure we're focused on what we're doing and eliminating those careless areas in there. But one more, check your understanding. The integral from 5 to 1 of 12x plus 3 to the power of 4. So you two could do your binomial theorem, expand that out
No.
if you wish.
I refuse.
How did you figure out that thing with the 6?
Yes, I'll have a look at it in a moment. I'll finish this one. Okay, so to integrate a function, we rewrite what's in the bracket, add 1 to the power, divide by your new power, multiply by the derivative on the bottom of what's inside the bracket. And because it is a definite, I don't need to include the constant of integration. Okay, and then a substitution.
Maybe that's why they have.
Look how funny. No, this is interesting. I think it's hard thing to do.
63 to the power of 5. Oh, it's
What was that?
63 to the power of 5.
I'm not going to try. Because I don't want to.
I could do it, I just don't want to.
I probably couldn't.
It'll take you a while.
I wouldn't be able to do it. Because I can't. Alright, 63 to the power of 5.
Oh, there you go. Oh, wait. No.
Well, you two could do it with your binomial expansion.
I-
Or you just got to go 60 plus 3 or the power of 5.
It's. It can be 63 to the power of 5. 992,436,000.
Well, you might as well just put all that in calculation, one
Yeah, it
calculation
is.
for me.
Take away
Heard that. Heard of numbers, alright.
15 to the power of 5. I didn't put it over 60.
So 63 to the power, 63 to the power of 5 over 60, take away 15 to the power of 5.
It's
Over
9
60.
points.
That's easy. Comic. You're an IT girl. You should get like snap. 2 to the power of 5.
IT, do you want me to do an IT? Khan Academy.
234.
No, come on. 2
I
to
see
the power of 5.
Okay, 2 to the power of 3 is 8.
2 to the power of 5 is
4 is 68, so
2 times 2 times 2 times 2 times 2.
32.
Can I have an answer from somebody,
Oh
please?
yeah.
No, but did you even know that before she said
The
it?
answer is 76.
Sorry?
The answer is 76.
I did not get 76.
I got
Really?
trust post straight away. The 156 thing has to count down.
I got 16,537,952.
16,500.
And 27,952.8.
Are you sure?
Yeah, that's what I got too.
Are you
I am bloody sure, Mick.
Do you want to check that?
63
Wrong.
take away
I've got the same
15.
thing as you.
Alright.
63 to the power of 5. Take away a really small number. That's why I think it's a big number.
That's why I looked at 76
It'd
and
be
was
like,
like,
what